There are planets out there that belong to no star. No sun warms them. No light reaches their surface. They do not orbit anything. They simply move, alone, through the absolute darkness between the stars, at speeds of tens of thousands of kilometers per hour. We call them rogue planets, and there may be more of them in our galaxy than there are stars. Some of them are heading in our direction right now. We cannot see them. By the time we could detect one on a collision course, we might have less than a year. This is what rogue planets are, where they come from, and what happens if one ever finds us. This is Beyond the Cosmos. We cover the universe one question at a time. Subscribe and stay with us. This one gets dark fast. A rogue planet is exactly what it sounds like. A planet with no star. Every planet you have ever learned about orbits a star. The sun holds everything in this solar system in place through gravity. Remove the sun and the planets would drift outward in straight lines, each one continuing in whatever direction it was moving at the moment the gravity anchor disappeared. That is essentially what a rogue planet is. A world that lost its anchor, or never had one. They are also called free-floating planets, interstellar planets, or nomad planets. The names all describe the same thing: a planetary mass object drifting through interstellar space, unbound to any star. They are not small. Some are roughly the size of Earth. Others are gas giants several times the mass of Jupiter. Their size range covers the full spectrum of planetary objects. What they all share is the same condition: complete gravitational isolation. They are cold. The surface of a rogue planet receives no stellar light, no stellar heat. Surface temperatures can sit close to absolute zero. The atmosphere, if one exists, would be frozen. Any liquid water would have solidified billions of years ago. From the surface, if you could stand on one, you would see no sun. No nearby star bright enough to cast a shadow. Just the distant smear of the Milky Way and a sky full of points of light that are all impossibly far away. Rogue planets are not formed in isolation. They begin like any other planet, in a disk of gas and dust around a young star. The problem is that planet formation is chaotic. Multiple large objects forming in the same system interact gravitationally. They tug on each other. Their orbits shift. In many cases, the interactions are stable, and the planets settle into predictable paths around their star. But in a significant number of cases, the interactions produce an ejection. A planet swings too close to a larger neighbor. The gravitational interaction gives it a sudden acceleration, a slingshot effect, that exceeds the escape velocity of the star. The planet is flung outward. It passes the outer edge of the system. The star's gravity weakens with distance. The planet does not slow enough to be pulled back. It escapes. From that moment on, it is free, drifting through interstellar space at whatever velocity the ejection gave it. Never decelerating, never turning, just moving in a straight line through the dark for billions of years. Computer simulations of solar system formation suggest this is not rare. Models indicate that for every planet that ends up in a stable orbit, there may be several that are ejected. Some estimates suggest the Milky Way alone could contain more rogue planets than stars. Hundreds of billions of them, possibly more. Most of them will never be found. Most of them will drift through the galaxy for the rest of its lifespan without ever coming close to another star. Silent, cold, and completely alone. Finding a rogue planet is one of the hardest problems in observational astronomy. They emit almost no light. They reflect no starlight because no star is nearby. They are cold, dark, and moving through a region of space where there is nothing to illuminate them. A rogue planet the size of Jupiter drifting through interstellar space is essentially invisible to a telescope looking for light. The primary method used to detect them is called gravitational microlensing. In 2011, a gravitational microlensing survey suggested that there could be roughly twice as many Jupiter-sized rogue planets as there are stars in the Milky Way. More recent studies using the James Webb Space Telescope have directly imaged candidate rogue planets in nearby star-forming regions, objects with no parent star and planetary masses, drifting freely through space. The scenario nobody wants to calculate. A rogue planet does not need to strike Earth directly to end everything on it. A close approach is sufficient. If a rogue planet passed through our solar system, its gravitational influence would begin disrupting planetary orbits long before any physical contact occurred. The outer planets, Neptune and Uranus, would be the first affected. Their orbits would shift. That shift would propagate inward through gravitational interactions over years and decades. A sufficiently close passage could perturb Earth's orbit enough to push it outside the narrow habitable zone. A few million kilometers closer to the Sun, and the oceans begin to evaporate. A few million kilometers farther, and they begin to freeze. Either outcome ends the conditions that have sustained life on this planet for 4 billion years. If the rogue planet passed close enough, the tidal forces alone, the gravitational differential between the near and far sides of Earth, would trigger massive earthquakes, volcanic eruptions, and ocean surges on a scale that has no historical precedent. A direct impact would be the end of the planet as a recognizable structure. The collision energy of two planetary bodies is measured in units that have no human analogy. There is no deflection strategy that works on a planet-sized object. There is no meaningful response. There is only the time between detection and arrival. Here is the honest answer. We do not know. The number of rogue planets in the galaxy is estimated, not measured. The figure of hundreds of billions is derived from models and limited survey data. The actual population could be significantly lower or higher. What we can calculate is the size of space. The distances between objects in the galaxy are enormous. The average distance between stars in the Milky Way is around 4 to 5 light years. Rogue planets are smaller than stars and move in unpredictable directions. The probability of one passing close enough to our solar system to cause disruption within any given million-year window is extremely low. Astronomers estimate that a stellar object, meaning a star, passes within about 1 light-year of the Sun roughly once every 100,000 years. The current scientific consensus is that a catastrophic rogue planet encounter in the near-term future is very unlikely. Not impossible, just unlikely at the level of other low-probability, high-consequence cosmic events. The universe is large enough that most of its dangers never arrive. But large enough is not the same as never. Right now, somewhere in the Milky Way, there are hundreds of billions of planets that belong to no star. Each one is moving. Each one has been moving since the day it was ejected from whatever system formed it. Some of them have been drifting for longer than the Earth has existed. We cannot see most of them. We cannot track them. We do not know their trajectories. We only know they are out there because the physics of planet formation demands it. The galaxy is not just the stars you can see. It is everything moving between them, in the dark, at speeds that make distance meaningless over long enough timescales. Most of them will never encounter anything. Most of them will drift through the galaxy for billions of years and then drift on into intergalactic space after the Milky Way eventually disperses. But somewhere out there, right now, a dark world is moving through the space between the stars. No light on its surface, no orbit to constrain it, going wherever the physics of its ejection sent it, billions of years ago. We just cannot see it yet. If this one kept you up a little, good. That means it worked. Subscribe to Beyond the Cosmos if you are not already here. Turn on notifications so you do not miss the next one. Like the video if rogue planets are stranger than you expected. And leave a comment below. If a rogue planet were detected heading for our solar system right now, what would you do with the time? I read every single one.